Yep.
All right, good. So chapter 9 is about finance. Some of this could be reviewed, some of this may not be reviewed, depending on how much you know about personal finance. So today we'll probably get through 2 sections, and then we'll do the other 2 sections on Thursday. Again, if someone has anything to add, please chime in if this is an area that you're interested in. I understand the math in these fields, but that's about as far as I go. So section 9.1, just like all the other sections, there's a lot into the definitions, right? So creating a budget, which is interesting because I always tell people I have a budget, but I really don't. I have an Excel spreadsheet that actually tracks my spending, not so much more as a set limit of budget, and more tracks what I spend. So really what a budget should be is something that tracks how much you're going to spend and not how much you are spending. All right, so the book kind of comes up with these ways to create a budget. So, bring in how much you have, right? So you should start with how much you're making, right? And then calculate your expenses, and then find basically the difference in the two, right? And if you're in the red, that pretty much means you've overspent. If you ever heard that saying before, being in the red, you overspent what you make, which in reality is what most of us probably do. That's why we get in trouble with credit cards and loans and stuff like that. You should set funds aside for savings, goals, emergency fund. The rule I've read in the financial world is it should be at least 2 months worth of income, which can be a lot. I can tell you right now, I don't have an emergency fund worth 2 months of my income. But that's what they always kind of recommend, of trying to put some money away to have for emergency fund. Kind of like right now, with people not being able to work and waiting for unemployment and all that to kind of kick in. The emergency fund, if you have 2 months savings, would be beneficial, but I think most people are lucky if they have a month savings. That's why a lot of people are running out of money quickly.
What we do is we have 2 months worth of bills set aside in a savings account.
Nice. Yeah. That's what they recommend. I have not been able to come up with that much money.
It dwindles from time to time, but finally Josh's unemployment came in and the extra came in for him as well. So good. We've been able to catch up and put some away.
That's good. And that's what we really should, all of us should do to help prevent from getting into this situation that some people find themselves in. And sometimes it's almost impossible. There's plenty of people that live paycheck to paycheck, unfortunately.
Does this chapter cover liquidity?
It does not in this book.
Okay, because that's important thing you want to distinguish when you're talking about like the 2 months put away. Is it 2 months put away cash, or do you have a stock account that you could liquidate and sell stocks if you had to? That would equate to
yeah. Yeah, that's true. I didn't think about that. I always think of a savings. So you're correct. If you have assets that you can move around that allows you to get funding, then yes.
Yeah. So if we're talking about like personal finance, it's important to have some cash on hand to get you through until you can liquidate other things that are less liquidable, like whatever, tangible assets, stocks, bonds. So yeah, I wouldn't say you need like 2 months cash, but you would definitely need like 2 months of something you could liquidate.
Yeah. That's probably a better way to definitely look at it. So some more definitions. So gross income is your income before taxes. Your net income is your income after taxes, basically your take-home pay. So your gross is kind of your hourly pay or your salary. Your net income is how much you take home after all the income tax, Social Security, Medicare, and all that. In the business math class, they really go into this pretty deep. We don't in this course, because QR kind of scratches the surfaces of a bunch of courses. But if this is something that really interests you, then Math 101 business math kind of really dives into a lot of this stuff. To even actually figuring out taxes, not doing your taxes, but how the government taxes you, which is a fun chapter to do.
Accounting does more with the taxes than business math does.
Yes. Yeah. If you take an accounting class, you definitely will get deep in the weeds. The business math class at least gets you through some of it where you get a better understanding of how it works. But yeah, obviously you go into the more the business classes, you can really get into this. So the pay periods, annually, semi-annually, it's every 6 months, so 2 periods, monthly, 12 months in a year. 7 monthly is 24 because you get paid and a half a month, which is kind of how the military does it. Sometimes they do it the 1st and the 15th. So that's semi-monthly versus bi-weekly, because there's 52 weeks in the year. You actually end up with 2 more periods than you do semi-monthly for those longer months. And then weekly, right? So when I was in the Army, for some reason, I picked the monthly and I just got paid once a month. My retirement from the Army is once a month, but my paycheck from CM is bi-weekly. So I get paid every 2 weeks from CM. So depending on where you work, that your kind of your pay period. And if you ever want to figure out how much you make annually, then you basically take your pay period, take how much you make in your pay period and multiply whatever pay period you are, and that will give you your annual amount. Some more definitions, right? So list price is the price of an item being sold to the public. Discount is the reduction of the list price, typically a percentage or a sale. Then our sale price is what the customer actually pays, right? So got our first math example here. All right, so you want to book tickets to travel during break. One day we'll be back on planes, hopefully. You find a plane ticket that has a list price of $129.99 with tax. The website is offering a 25% discount off the list price. So what is the price of the ticket now, right? So just like we did in our ratio chapter, I can't remember which number that was. This is very similar. So if I take the current price and I multiply it by the discount, that will give us how much we're taking off, right?
Yeah. Why don't we just multiply by the complement?
We can do that as well. I was going to show both ways. Dylan's ahead of me.
Sorry. Well,
no,
I thought the other way would have been simpler.
It would, but a lot of people don't recognize that. Many don't recognize that way until they start understanding how the complement works.
Maybe it's
right? It is much simpler. Dylan is correct, right? If I take 129, if I have 25% off, that means I'm paying 75%, right? This is how my wife does it faster than I can too. So the tickets cost $97.49. If you do it the way I was starting, then you have to take that number and subtract it from $129.99. So 129.99 minus the 32.4975. And you get the exact same answer. So, and that's why I'm hoping we can start to see here, right? So this is what typically most of us do until we really start to understand the process. We know we take the 25% and we have to subtract how much we saved. But Dylan is completely correct. If I pay 25%, if it's 25% off, I'm paying 75% of the original cost. All right, so now you go to book a hotel, you see a list price of $330.75. However, if you book now on the website, you'll only pay $198.45. How much discount do you get? So what would we do here? How would you figure out how much discount?
You always want the total of the whole in the denominator, so the list price is going to be that.
Okay.
And just put what you're paying in the numerator.
There you go. Another ratio problem, right? So you can see a lot of the math that we've already learned in this course applies to a lot of real world applications. And that's a lot what this chapter is going to do. This chapter is just really taking things that we've already done, the concepts we've learned, and applied it. So this equals 0.6, right? So what does that mean?
What is the percentage discount? The discount's 40%.
There we go. So again, this is how much we pay. So you gotta be careful. The answer is not 60%. This is how much we're paying. Okay, my eraser goes off. This is how much we're paying. So our discount, I can't spell today either, is 40%. We're paying 60% of the original cost. So our discount is 40%. No questions? So one thing that I see that, and what is weird about this is I was helping someone do some analysis in Trio once, and I was surprised to see that this is not a standard formula. Lots of different ways to do percent change. They're all very similar, but I thought it was very interesting that doesn't seem to be a strict formula for this. But, you know, when you see things on percent increase or percent decrease, you can't just add the percentages together. You got to use this formula where you take the new value minus your reference value, which is basically your starting value, and divide by your starting value, and then times that by 100%. If you want to figure out how much something has percently increased or decreased, right? So you're telling some of your friends that you're going to go on this trip during break. They decide that this sounds fun, so they too buy tickets. Your entire trip costs you $900. Their trip now costs them $1,200. What is the percent of increase on the trip, right? So the percent change is the new value is the $1,200. You're going to subtract off the reference, which was the $900. And then you divide by the reference, which is 900. And you got to make sure you have the parentheses in there, because if you don't, you end up canceling parts of a polynomial, which are bad. And then times it by 100 to add in the percent symbol. So 33.33% increase.
Yep.
Does that make sense?
Yeah. Yeah, I always
So a little
remember
bit
that change over the
What?
original.
Yeah.
But when I do that in Excel and format the cell for percent, I don't need to multiply by 100, right?
Correct. Yeah. And that's one thing a lot of times people get confused about, right? And we'll see this in 135 as well. Multiplying something by 100 adds this symbol, right? So if you use that symbol in Excel or your calculator, then don't do 100, because the calculator already knows to do the 100 because of the symbol, right? So there's a lot of formulas that have this whole times 100 or divide by 100 in statistics, and it's just to add the percent symbol, right? So,
Gotcha.
yep, which is a good catch. A lot of times students don't understand why, well, not just students, anyone in statistics doesn't understand why you multiply by 100. Then they throw a percent symbol on it and they get this huge number.
Yeah, well, I did that formula and then I formatted the cell for percent and got 3,333%.
Yep. So that's what we got. That's what the whole point of that one. So if you turn something to a percent, don't multiply by 100 again. And if you say you were going the opposite way, right? And you're like, okay, 33.3% is 0.333, right? Then some people are like, oh, but the formula says to divide by 100. Well, the whole point of dividing by 100 was to get rid of this symbol and to move the decimal. So you always be careful if the symbol's already gone, don't use the 100 again. But good job. I mean, good bringing it up, because I wouldn't have thought to say it. So that's basically all 9.1 was. A couple definitions, not a lot to 9.1. And I think for the project, I say for you to kind of calculate your own budget, I believe is what I asked you to do. Is that what it was for this project? Let's see. 296.
Yeah, it's a budget. You do your budget.
Okay, perfect. So, and I think I asked a couple more questions though, don't I? Let's see.
Yeah,
budget.
you want me to
Oh,
tell you
no.
what they are?
Oh, sure.
Oh, hang on.
I can get it too.
All right, that's yeah, you can get it. I need to exit out and not save. I hit space bar to talk and
Yeah.
delete it.
Yeah. So create a financial budget or financial plan to purchase or save a future goal. If you do a budget, include the percentage of your income for a savings or emergency fund. Why did you establish this percentage? If you're building a financial plan to save money for purchase, explain the payment amount and the future value amount. If you're building a financial plan to borrow money, calculate. So depending on what type of plan you're doing, that's the lessons we're learning here on this one. I don't know what the book has you doing. I think the book gives you numbers and just wants you to calculate. We got our pesky mosquito model. What else we got here? Come up with your own game. Sending the curve, all about gradings. Yeah, curve gradings in school, what it really means. Paying it back. Yeah, so the chapter 9 one, this one is saving for college and all that stuff. Yeah, they give you some data. So they actually want you to work through their numbers. So whatever one, there's all kinds there you can kind of choose from. But not a lot to 9.1. Just some of the stuff should look familiar because we've done a lot of these calculations before in our ratio chapter. And a lot of these definitions I think most of you have seen. So no questions. Understanding interest. This is always the fun one. So I'm going to go through a couple interest formulas, which is back in 2008 with the whole recession and the market crash and the housing market. I can't even think of the word I was going to say now. Mess. Let's call it a mess, for lack of better words right now.
Crisis.
One thing that did come out, do what?
Housing crisis.
Yeah. One good thing that did come out of that, though, is the government passed the law that credit cards now have to put on their statements if you make this minimal payment, how many years it'll take you to pay off that credit card debt. Because people are just paying off the minimum balance and not understanding why their credit card balance was not really changing. So they made them add that for people because they didn't understand how interest works, right? So that's what we're going to kind of talk about here, the different types of interest. And then we'll probably be stopped there. So, yeah, two formulas here. So let's go through some of the definitions and the good news is through 9.3 and 9.4, a lot of these symbols mean the same thing. So that's, once you get the symbols down, that's a good thing. So I is the interest, right? And what people get confused of is they think I is the interest rate. No, I is a money balance. It's how much money is being charged or earned, right? So it's the amount charged by the lender for borrowing money, bank accounts, loans, credit cards. Principal is the amount of money in which interest is being charged. I like to call this the starting balance. That's where I start. I mean, definitely that's not the proper term because your principal changes every month. But the way I like to do it is you kind of look. That's where I like to think of as my starting value when I'm solving these type of problems. Interest rate is the percent charged on the principal. So this is where the rate is, and you can see it is a percent, which means it has a percent symbol. So like Kyle said, you have to do the whole, divide by 100 or use the percent function in Excel or your calculator to get it into a number you can actually use. Time is the interest is being paid, and it's usually in years. That is the key. A lot of times, some of the problems that people get them wrong is they change it up on you, and you start to ask, well, how much we have to pay in the next, 4 months. Then you have to convert things from years to months because the time is typically in years as well as the interest rate is based on years. And that's why it comes up with this thing right here. The annual percentage rate is the yearly interest rate. Compound interest is an interest that is charged on both the principal and that's accused. That's supposed to say acquired interest. Can't spell acquired either.
Accrued.
All right, how do you spell acquired? Is it
Accrued.
spelled with an O? Is it accrued? That was the right word?
Well, you're writing accrued, but it's ACCRUED.
That one.
Yeah.
How do you properly say that?
Accrued.
All right. I say it wrong. That's probably why I can't spell it.
How do you say it?
And the much. Now I can't even think how I say it. Now you said it. That's all I want to say is accrued. All right.
You were thinking
Accrued
acquired,
interest.
but accrued.
Yeah. How much interest you have earned? There we go. This is why I did not do well in my English part of my SATs. Don't know big words, or pronounce them right. So both the principal and how much interest is now been occurred on your account over a specific time interval. The time interval that compound interest is being applied is typically represented by the letter N. All right, so that's kind of how often, a lot of times books call it the period, is what you will calculate off of this. Future value is the total amount at the end of the loan, which is typically represented by an A. This is where you know your symbols a little bit, because the two formulas give you very similar answers, but not quite the same. I'm not even talking calculation, it's just extra steps depending on what you're trying to answer, right? So the first formula we have is simple interest. I equals PRT. And I honestly don't know anyone that uses this formula anymore. Every financial market that I know uses compound interest or some form of that type of formula. But there, a lot of times in math, we start with this nice simple interest formula because the calculations are pretty straightforward. So our simple interest formula is I, right? And that's how much interest you're going to owe or receive, depending on who you are, if you're the person borrowing or the borrower being borrowed from, sorry, equals principal times your interest rate times time. So how much interest will you owe to a friend who loans you $1,000 for 2 years with an interest rate of 5% using simple interest, right? So now it's just really putting information into the problem. So 1,000 times the interest rate of 5%, so that's 0.05 times 2 years.
$110.
So you will end up paying them $100, right? Now, typically, that might be how a nice friend is, because that's easy math, right? That's why I went with friend here. If you go to your bank, they're going to use this thing called compound interest, right? And the compound interest formula is A, which is how much you owe at the end, equals principal times 1 plus your rate divided by your N, how often it's compounded, raised to the NT power, where again, N is how often it's compounded. So, get my space a little room here to work, right? So to do this one, I guess I could put up here, I equals. So A equals 1,000, parentheses, 1 plus the rate, again, is still 5%. And it's compounded monthly. So therefore, I put this as a 12. And I raise it to, it's again, still 2 years, so 2 times 12. So 1,000 times, parentheses, 1 plus 0.05 divided by 12, close parentheses, raised to 2 times, plus 2 times 12, or 24, gives me an answer of 1104.9 4.94. Not a huge difference. So again, this is where you have to be careful. Remember, simple interest tells you how much interest you're going to owe. So to figure out the ending balance, you have to take your previous balance of 1,000, add your interest, and you get $1,100, right? Versus the compound interest, it ends up telling how much you owe. So if I want to compare interest, I have to subtract my principal, right? And then I get 104.94, and that is how much interest I am now paying. So the formulas, like I said, they're similar. Not just the values are going to be different, but what they tell you is different. Simple interest just tells you how much extra it's costing you. Sorry, compound interest tells you your ending balance.
So it's the same interest rate in the same time period, and you pay $4.94 more if you use the compound interest formula.
Yep, because your interest is getting put into the figure, and also the formula is getting applied every month versus simple interest where the interest is not being added to the balance, but at the same time, the interest is only being looked at yearly.
Yeah.
Okay, so really, it's just a complex way to make a little more money.
Yeah.
Yep.
The interest
Awesome.
on the interest.
Yes. So this is how credit cards get
on the interest. Is that what you said, Dylan?
Yeah, the
Yep.
$4.94 came because you got interest on the interest that they were getting. So the $4.94 is the interest on the $100 of interest.
That's terrible.
And the more times they compound it, the higher that number is going to get. If they only compounded it annually, it would have been
fairly close.
Gotcha.
Yeah, I think you would have been actually really close if we would do it annually. Let's see what it would be if we did it annually. I gotta stop hitting all clear. Then I can go much faster on my calculator. 1 plus 0.05, close parentheses. So now you don't have to divide by 12, raised to the 2 power. Yeah, well, they still make $2.50. Yeah, and this is why banks do that. And most banks are, I think, daily. I think they are compounded daily. So what credit cards give you is they give you that whole 25-day grace period, right? So that's why if you pay off your credit card every month, you get no interest. But as soon as you miss the grace period, then they start applying that interest rate daily. So every day you owe more on your credit card.
I get it.
So that's why sometimes you'll pay off your credit card and then you won't use it, but next month you'll get a charge for like $1.35. That is the interest on the interest, like Dylan said, that they charged you because it took that few days for them to process your payment.
That seems like robbery to me, but
yeah, that's why during the housing crisis, that's one thing that came out of it. So that's why Congress actually passed a law. And if you look at your credit card statement, it has that little blurb at it's in a box now, where it says if you pay the minimum payment, it'll take like 17 years to pay off this credit card.
cool.
And they had to put it on all credit cards because people didn't understand how this formula worked, and they didn't realize what these companies were doing to them.
Oh yeah, no, totally. I don't understand how they work, and I've been paying on them on interest, for at least 15 years now.
Yeah, and that's why when you buy a house, they always say you pay the interest up front, right? Because they have you paying a percentage of the interest on interest every month. That's why when you first start paying the house, your principal goes down extremely slow because
Gotcha.
70% of your payment goes towards the interest that they just gained on the interest.
All right, I get it.
That's why they say, and we'll get into this a little bit with the saving money and borrow money, but if you read financial, articles, if you just make one extra payment on your house a year, you'll knock 10 years off your mortgage.
Oh,
And it's because you reduce the principal quicker, so they aren't getting as much interest on interest.
Right. Huh. That's wild.
Yeah, and just one payment. All you have to do is make one extra payment a year, and you'll take 10 years off your mortgage, approximately. It all obviously comes down to interest rate and all that stuff, but that's the quick math behind it. So I found in the book, and I tried to Google to try to find out where this formula is used. I have not been able to find it. Let me put some spaces in here so we can get away from my writing. But they have a continuous compound interest formula that's based on the exponential distribution. Yeah, we did exponential modeling, right? So it's very similar, but it increases exponentially versus, but the big difference in the formulas, this piece is now exponentially instead of 1 plus the rate. And it's the rate's part of the exponent, so it increases much quicker. I tried to find where this is used in the real world, and I had not been able to find it. Every time I kind of Googled it, it just came up with the formula and it gave me examples how to apply it. But I couldn't find any financial market or anything that follows the exponential interest rate.
Loan sharks.
That might be the case. I didn't even think about that because not only loan sharks, but those money marketplaces, that you can go just walk in with the title of your car and they'll give you like $500 till the next pay period kind of thing.
Yeah.
The rate and how much you owe them is ridiculous amounts. I don't know how those things are legal, but they are. And that might be where I definitely tried. I had to ask some people that teach in the business department where this formula is ever used, because the book mentions it, gives an example of just saying apply this problem to use this formula, but it doesn't give any real world example. So I didn't really come up with one either. What is very interesting and still a little confusing to me, their annual percentage yield and APR are two different things. So when you go to apply for loans in banks, a lot of time they give you the annual percentage yield and you think that's the rate you're paying, and it's actually not. Is actually not. So how you find that is I came up with this little table here. So what is the annual percentage yield for a deposit of $5,000 for each example on the table, right? So I kept the annual percentage rate the same, and all I changed was how often it's applied. So one's monthly, one's weekly, and one's daily. So to find our first annual percentage yield, right? So I got brackets just to keep my little stuff a little neat here. I do 1 plus the rate, which is 0.075, all over my n. So if it's monthly, that's 12, all raised to the n. Well, don't put in n, or n, which is 12. And then you subtract out the 1, and then you times it by 100%. So go to our calculator, bracket, 1 plus 0.075 divided by the 12, close bracket, raised to the 12th power, minus 1, close bracket, and times it by 100 to add the percent symbol. And for my monthly one, I get an annual percentage yield of 7.76%. Dylan, you said you were a business major for a little while, or you took business classes?
Yeah, I got a business, an associate's in business.
What is the difference between, if you don't know, that's fine, I don't, the annual percentage yield and the annual percentage rate?
So come help me find mine if you're so sure I have them.
Isn't, I was kind of tuning out for a second. The yield, because the yield looks like a
Man, I took this years ago. I didn't know the yield was a percentage. I thought the yield was actually like the annual. I don't know. I don't know. I'd have to look at it.
Yeah, when I did that formula the same way as you in Excel, I got a number, not a percentage.
Well, it times it by 100, so that makes it a percentage.
Well, if I read it as a percentage, it's 1,107.5%.
Yeah, you have a percentage, and then you times by 100, take the percent out. It's the actual yield. It's the total interest.
Yeah, that's because we started with that 7.5%, and then we multiplied by the 100 to take it out.
I think you get APY in dollars.
That's a tow truck, not a flatbed.
What? It's a flatbed tow truck.
Kidding. It's not actually a flatbed because that tow. Oh man, it would go right here.
Wow. So at least I know the financial world is as bad as statistics, where it's not standardized. But according to Credit Karma, annual percentage yield is the rate at you earn money, and annual percentage rate is the rate at which you lose money. So if you're borrowing, it's APR.
Oh.
If you're depositing into your account, it's APY.
There you go. That makes sense.
Well, that makes
But
sense.
then that's so weird that there's a formula to convert the two then, though. And our book is not a business book, so it does not go into great detail of the whys, which I don't care for. Because I like to know the why before I teach it. So when students ask me the why, I know the answer. But this book does not. So we'll flip it through our book right now to get to annual percentage yield. Yeah, the annual percentage yield is the effective interest rate earned in a given year that corresponds to the effects of compounding. Yeah, and so in the book, they have everything as a percentage. Did I do this? No, I changed the number, so it's different in the book. So Samantha's investment, compounded monthly, gives her a yield of a 5.116%, I guess, increase is what they're calling it.
Let's see, 0.075.
Yeah, I'll have to get with some business person to kind of explain this a little bit better for me if I teach this in the fall. Sorry, I don't quite get it, why it's the difference, but everything keeps saying that's just their yield based on how often it's compounded. And it's in the book, it's all percentages.
Yeah, no, you're right. Yeah, so the yield's going to go up, and then the APR is going to go down.
Yeah. So, but Kyle, did you figure out what went wrong with your Excel though?
No, I did not.
Yeah. So if you're hitting the percent symbol, right, you're just hitting the percent symbol. So you don't want to put that in. So what you got to be careful here. Before you can subtract this 1, you have to raise everything to the 12. So if you type this in Excel, you should do equals parentheses 1 plus 0.075 all over 12, close parentheses, then I think it's that shift 6 to put that little key in, 12. Now what I wonder is if you do -1 now, does Excel think you're putting the -1 on that? Try doing this in Excel. Put another set of parentheses like this and see if it works. And then hit your little percent key that you're doing.
Wait, put another set of parentheses.
Yeah, put the black ones in that I just drew.
Okay.
because I'm thinking Excel is for some reason subtracting the 1 from that 12. Let me try it in my Excel to see if I can get it to equals.
Yeah, it's
Parentheses.
telling me there's a problem and to use an apostrophe in something.
So equals 1 plus 0.075 divided by 12, close parentheses, raised to the 12th power minus 1. Yeah, mine worked. I didn't, yeah, and in mine, I didn't have to put in these second set parentheses. I just typed in just like that. Get rid of my arrow. I put equals, parentheses, 1 plus 0.75. Make sure you hit the right division key on the keyboard. It's this guy. Divided by 12, close parentheses, then shift 6 to get this, the symbol there. 12, and then minus 1. And then if I hit my percent symbol, home, yeah, mine rounds up to 8, but I can push the arrows over. Yeah, and I get the same answer. And you can try sharing. I can stop sharing if you want to share your screen. I can try to see what's going on.
Nope, I got it. I figured it out. I got it. Yep.
Okay, good.
I just had some more parentheses, I think, originally.
Yeah.
Oh, and I didn't do the up caret.
Oh. So let's see what happens if we if it gets applied weekly for us. So 1 plus 0.75 divided by 12. Nope, not by 12. We're doing weekly now. Dividing it by 52. All raised to the 52 power. Subtract 1 times 100 to get a percentage. So this time I didn't hit clear on my calculator, so this will be a little quicker to type in. I just got to replace my 12s with 52s. So I got 7.78%. So not a big jump, but a little bit better yield. And our last one, our annual percentage yield, bracket 1 plus 0.75 divided by 365, all raised to 365 minus 1 times 100. Yeah, that didn't even jump even more, so it definitely doesn't climb quickly. Only went up a whole 1/100th of a percent.
Just to be nitpicky, you got 0.075 on the first equation.
Oh, did I?
Yeah, if you're saving this. Somebody might read that wrong. No. We're plugging into the equation.
Oh,
Not the answer.
oh, I got my decimals in the wrong place.
0.075.
Yeah, these all should be out here, right? Because that's 75%. Not, yeah. So these shouldn't be like that.
There we go.
Yeah, and I should be technically correct to put those 0 into 1's place. All right. So the next two sections goes into saving money. So these formulas help us predict how much value we'll have in the end. So we'll do some of those problems in the next class, as well as how we save money and how to do down, how much money we should put down to get the payments we want for borrowing money. So a little bit of saving money, a little bit of borrowing money next class. We don't get into the whole fund stock market, sorry. We just get into some of the small loan type stuff in our QR course. So finishing a little early today, but we don't really have a lot